This is activity 2. Just going to start by writing my name on the checklist sheet. Then we're going to move on to noting the resistances of the 3 different resistors by their color codes. So you can see I've done the math here for each resistor. So there's a 10 ohm resistor, a 56 ohm resistor, and the 120 ohm resistor. 2 times 10, 120. So we can check that off now. Now we're going to measure the resistances of the 3 resistors using the lab multimeter. So this is the 10 ohm resistor, and you can see we've got 10 ohms. This is the 56 ohm resistor, and as you can see when I pan up, we have 55.9, which is pretty much 56, so within the expected value range, and the 120 ohm resistor, 119.5, again in expected value, so we can tick that off now. Now we're going to draw the circuit schematic. So as you can see here, I have it drawn already with its very basic circuit, 3 resistors, and then the 7-volt battery. As you can see, that's the schematic, so we can tick this off now. Now we're going to calculate the current that would flow through the resistors if they were connected using Ohm's law. So we'll start with the 10 ohm resistor and then adding on the 56 ohm and the 120 ohm. It's a very basic calculation. You get 186 ohms. So if we use our equation here of V equals IR, we can rearrange it as I equals V divided by R. So current equals voltage divided by resistance. So I equals 7 divided by 186. So we're going to bring out the calculator to complete this calculation. So inputting the calculation into the calculator here. So we can now take that one off. Now we're going to calculate the expected voltages across each resistor using Ohm's law. So we're going to start with our Ohm's law again. I equals 0.0376. We know that V equals IR, so V equals 10 multiplied by 0.0376, and you just move the decimal place by 1, 0.376 amps, which is also the same as 376 milliamps. And you can see we cross-reference to the earlier calculation, they are the same. So if we use our equation again, subbing in 56 by 0.0376, we'll use the calculator to do that now. And we get the result of 2.1056. It's doing the same for the 120 ohm resistor. We're just changing 156 for 120, and we multiply them again. One sec. And we get 4.512. So we can now tick that off. Now we'll demonstrate using coarse and fine tuning using the DC supply machine here. So you can see here is the coarse tuning. It kind of rapidly increases and decreases the number of volts by a lot. And if we use the fine tuning, it will mainly only affect the decimal places, so it won't affect it as drastically. I'm going to need to remember to turn that off first though. So now it will work. So you can see our max current is about 0.039 amps or 39 milliamps. So if we come back to here, you'll see it's 0.0376 amps, which is very close to 0.39. That's how we know it's right, and we can take it off. Next, we have to connect the DC supply across a circuit with 3 resistors in series. So you can see I've got that set up here, very simple. Resistors connected all in series to the DC supply. So I'll pan up here to the DC supply, and you can see these are the values that we've got. Once I turn it on, you'll see it's still the same, the max current, 0.037. So we'll turn that off, and then we can go back here and tick that activity off as well. You can see it's still the same as the earlier calculation, so we know it's right. Now we'll show that the current flowing from each bench supply is displayed. The off button is pushed in. We just did that, so we can tick that off as well. Now we'll show the effect of setting the current limit to half of the expected limit, which we demonstrated in step 5. So we'll go back to the DC supply, and we will reduce the current to half of this, which is roughly 0.018. So we're going to have to fine tune the current.
So yeah. Do you know what? The TC. Oh, that one. Yeah. Right. So what you're gonna do is basically. You obviously draw this. Yeah. So because I want to break.
And now you'll see that the volts drop to almost exactly half, 3.24, not quite half of 7, but within the expected range. So close to 3.5. So we can tick that off. Finally, checklist shown and updated throughout the video. We've been doing that. And so that is the entirety of activity 2. Thank you for listening.